Hi everyone. In this lecture, you are going to discuss about what is meant by data type and how the data types are stored in a C program. Okay. So let me quickly discuss what is meant by data type. The data type is how we enter the data in our program. Data is what? Your input. How can you pass the input into our programs? So basically in C program, there are different ways to pass a input. But in a real life, what? You can tell them what you can pass the text as an input, or you can pass the video as an input, or you can pass the audio as an input. But in a C program, there are different types of input or different ways you can pass the data. So how we can enter the data into our program and what type of data it is. Okay. So data types in C are broadly classified as primitive data type and derived data type. Primitive data types are fundamental data types. Okay. Primitive data types are what? Fundamental data types. Whereas derived data types are not, we are not going to create any new data type, but we are adding some functionality to the existing data types. Okay. So adding some functionality to the existing data type, which is called as derived data type. So there are four primitive data types are there. One is an integer. Okay, the short form is int. Another one is an character. The short form is char, and floating point number, and then double. So totally four primitive data types are there. Whereas in derived data type, array, structure, union, this is called as enumerator data type. In short form, you can say it as enum and then pointer. So five derived data types and four primitive data type. In this lecture, we are going to elaborately see the primitive data types. So the first one is called as an integer. The whole thing which we are going to discuss about integer. So that's based on the size, it will be varied, and most probably the integers we could say it is a real number, whereas in the floating point numbers are called as decimal numbers, or we could say it is a fractional number like 0.0 or 0.1 or 0.5 or minus 0.5. So these are called as floating point, whereas integers are real numbers 1, 2, 3, 4, or else 0, -1, -2. It will be keep on going, but based on the some size, it will be stopped. So based on the size, and the size will have a ranges. Okay. So the first one is an integer. Even if you are not specifying anything before the integer, it will be treated as a signed integer. Signed integer means which support positive number as well as negative number. Okay, signed integer means what? Positive number as well as negative number. So that's why here the size is 2 bytes. All of you know that 1 byte which is equal to 8 bits. Okay, 1 byte is equal to 8 bits. So 2 bytes, 2 into 8, which is equal to 16 bits. So if it is a signed, the 16th bit, which indicates the sign. So if it is positive means 0, negative means 1. So the rest 15 bits, you can store the value. So 2 power 15. Okay, definitely the answer will be 32,768. So you can store that many values. Why? Because the 16th bit is signed bit, either positive number or negative number. Whereas unsigned int stores only positive. So 16th bit is also included. So the size will be defined as 0 to 2 power 16 minus 1. So which is equal to 0.0 to 65,535. So actually 2 power 16 is 65,536. 536 minus 1 because I have included 0. So 65,535. Whereas it is in the signed bit, one bit is lesser, so it will go up to 2 power 15. 2 power 15 is 32,768. Obviously, it will go to the negative number as well as the positive number. Sir, why positive number only 767? Because we are including 0. Okay, fine. So this is the size. Based on the size, it will be defined. So short int, signed short int, if you are not included anything, then obviously it will be treated as signed short int, which is equal to 1 byte. So it indicates 1 into 8, which is equal to only 8 bit. So that's why minus 128 to 127. So the 8th bit will indicate the positive number or negative number. Totally you can store 7 values, 2 power 7. So obviously the 2 power 7 is 128. So how will you say that 2 power 7 is 128? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. This is the 8th bit. Okay, totally 1, 2, 3, 4, 5, 6, 7, 7 bits. Okay, this is 1, this is 2, this is 4, 8, 16, 32, 64. If we sum all those things, you will get 127. Okay, if you sum all of the things, you will get 127. Okay, so 2 power 7, which is indicates that it is the signed bit. But whereas in the unsigned, it is having only positive number. So 2 power 7 is also indicated. So 128, if you add all those things, you will get 255. So if it is a signed bit, means the most significant, the MSB, they will say that MSB. So if it is 8 bit, 1, 2, 3, 4, 5, 6, 7, 8, this is LSB from left hand side, this is MSB. If it is a signed number, the MSB is used to store signed. But we are not going to store it as a sign, we are going to as a 2's complement. Okay, 2's complement number. And whereas long int, the size is 4 byte. So 4 into 8, which is equal to 32 bit. That's why the range is differed. Unsigned int, the same criteria. So unsigned means 0 to 2 power 32 minus 1. So here the 32 bit, 32nd bit is used to store sign. So this 2 power 31. Whereas if we will go for a float, float will store the decimal values. That's why here E is represented. E to the power of minus 38 means you have to move the point to this side towards this direction. E to the power of plus 38 means this direction. So like let us assume that 3 power 4 into the exponential power 10 power minus 2 means we can say 0.0034 actual value. That we can write it as 3.4 into 10 to the power of minus 2. Sorry, the point will be written here. Okay, if it is, you can write it as 3.4 into 10 to the power of minus 2. 10 to the power of minus 2 means like not minus 2, 10 to the power of minus 3. The meaning is what? 3.4 divided by 1000. Obviously, you will get 0.0034. It will keep on going like this. You are moving this side. Okay, so the same thing for positive. So only the exponential gets deferred. Okay, so like that's why it is divided by 1000. Like exponential, based on the exponential way value, the size get deferred. And double, which occupies 4 bytes, so 8 into 8, which is equal to 64 bit. Okay, so 64 bit in the sense like what? So 0 to 2 power 64 minus 1. Here I am not specifying unsigned double or signed double. It is a double. That's it. Okay, and then long double means 0 to 2 power what? 10 into 8, which is equal to 80 bits. So 0 power 2, 0 to 2 power, not 0 to, sorry, sir. This is not 0 to, maybe it conditions from minus. Everything is minus, not 0 to. So that minus means that 64th bit may be a positive number or negative number. So here they are deliberately, they are not saying minus, that keep on 0.000 likewise. That's why the exponential value will come here. Okay, So this is what like the exponential value here. That's why minus 3.4 e to the power of minus 32, which means the negative number will also be there. Okay, here also negative number minus 1.7 e to the power of minus 3 to 08. So based on some value, it will get changed.